So in this video I'm going to show you how to set up the base for a basic first-person shooter. If you look at the console down on the left, you can see that I can damage him by shooting the server. I can also damage here, and everything is kept track on the server. It's basically only the shooting that is client-side. So first things first, this example of a shooter is going to be client authoritative, which means it's not necessarily hacker proof. I just want to get you into making your first FPS with Fishnet multiplayer. So I've just have this base project here already set up, which is my main how to make multiplayer in 7 minutes tutorial. It's the exact same scripts. It's just the player controller. I have a character controller, a capsule collider, and then I have the network object, network observer, and network transform. The network observer allows you to send observers RPCs. You can look more into my RPC video or remote procedure call video about that. And the network transform is what just sends information about the transform, which means the position, rotation, and scale over the network. So this also means that this is not going to be highly competitively viable because there is going to be some delay. If you do want it to be highly competitive, if you want to make a game like Counter-Strike or Call of Duty, let's say, you need to look into what's called client-side prediction. And this is something I will be looking into in the future, but it's a really advanced topic. I need some more time to get into it. It's not something I'm working really hard on right now, but it is something I will get down later on and make a video on. So in case you can't wait for that, this is probably a good place to get you started making a first-person shooter. So since we do have the base player set up, what we basically need to make him do is we need to make him shoot. Now let's make a new script, and I'm just gonna call this player shoot. Now first of all, we don't want other players to be able to interact with this script, so we need to make it a network behavior script. Of course, first of all, we've got to be using fishnet.object. And then we make the script a network behavior. Now, one thing that I've also actually been getting a bit wrong is I've typically been going into the public override void on/client function, and I've been disabling the script in here. Now, this is actually not the proper Fishnet behavior. I've been made aware. I have not had issues with it. I can say that much. That being said, they are telling me that there are some unexpected behavior if you do this. So let's not do that, and let's try and do it the proper way. Now, one thing I also haven't explained properly in previous videos is the on-start client is basically your start functionality. So instead of using start, which you actually don't want to use in this case, you want to use on-start client because this has been called in the same sort of way, just as a network behavior script instead. Now, we also want the update functionality, and the proper way where you actually check whether you are the owner of the object or not is actually every time that you run a functionality, you pretty much just want to return. So we're just going to say if base.isOwner, and then we're going to reverse this and then say return. Return means that you leave the function as soon as you reach return. So this means that if you are not the owner, you will reach return and you will leave update, which means everything that we write down here and well below this point will be the owner only interacting. We can do the exact same up in the on-start client functionality, and everything that we write here will only be the owner, and everything that we write above will be everybody. Now, just to keep things clean, let's also make a void shoot, or a function or a method. This void shoot is what we're going to be calling every time that we press our button. So one way that I like to do things is I like to have a bool that just says can't shoot. Let's by standard set this to true. What we'll then do is we're going to say if input.get button down, get key down, or get key rather. And then I like making a serialized field as a key code up here, which is going to be our shoot. And then we can just put the shoot key in here. We can actually also just set this here, which can be key code dot mouse 0, which is the primary mouse button. So this means whenever we left click, we're going to be triggering the shoot key. And then down here, we can call shoot. And in this print, we can say this, however, does mean that whenever we hold the button, it will absolutely go nuts with the shoot functionality. So something I like doing better is actually starting a coroutine for setting whether we can shoot or not. So let's say if we press down the shoot key and we can shoot. Then down here, we can have an IEnumerator checking whether we can shoot or setting can shoot. So let's just fire this one and call it can shoot updater. And in this can shoot updater, we want to wait for some time before setting can shoot to be equal to true. This will be our fire rate. So let's set the fire rate. I'm going to do serialized field, float, fire rate. And let's just set that equal to, let's say, once every 0.3 seconds. Now, a float that we also want immediately could be all, let's say, an int will be our damage. Let's put that equals to, I don't know, 5. So an IEnumerator is basically what we call a coroutine, and coroutines have some bit different functionality, which basically means it can run aside other functionality without having to sort of stop and wait for it. So let's say that we are loading a large file and we want to return some of the data, we can actually do that in a coroutine. Now this isn't really what we're going to be using it for. We're going to be using it as a very basic timer. But one thing that you need to use is you need to have a wait for seconds is what it's called, which is what allows us to wait. And we're just going to call this shoot wait. And down here, it's important that we need to set the shoot wait equals to a new wait for seconds. This is just how it works, very standard. And we set the time equals to our fire rate. This means that every time that we call shoot wait, it will wait for this amount of time with the fire rate. So we can say yield return shoot wait. And that means whenever that we call the can shoot updater, it will fire the timer first, and then once the timer is done, it will return the can shoot to true. So that also means that up here, we will set the can shoot equals to false, because we do that first. And now down here in shoot, we can run the coroutine. So we can say start coroutine can shoot updater, like so. And now let's go and test it out. It is of course important that we add the script to the player. You can see everything is set up, and let's go. So now whenever I press the button, you can see it says player shot. If I hold the button, you can see that it counts up with the timer waiting. Now if we go out, this does however mean that we cannot dynamically change the fire rate because of the way that we've set it up in the start functionality. Let's say, for example, the fire rate is 1, and let's enter again. And now when I hold it, you can see it will count up 1 every second. This means that the shoot functionality now works as intended, and now we can actually start working on what actually happens inside of the shoot. Let's keep the player shot print, and now let's actually fire off the raycast. So first of all, let's fire the raycast inside an if function. So we're going to say if physics.raycast. So the first thing that we got to do is where does the raycast fire from? Now the way that my setup at least works is that we only have one camera in the scene, which is local to the player. It's not a multiplayer camera, so if the camera moves on my screen, it doesn't move on the other player's screen. This means that we can actually use the camera.main.transform.position as the position of the raycast, and we can still use the camera.main.transform.forward as the direction of the raycast. Now we also want to output, so we can say out raycast hit, that we call hit. Then there is the range, which in my case is going to be mathf.infinity. And then we can put some layer mask on here, which we will just call the player layer. So now that we've made the player layer, I'm going to put it in here, and boom, now we got the entire raycast. Now let's open up this if statement. And this actually already basically means that that if we've hit anything, it is for sure a player. Let's go set up the layer for our player. So I'm going to go to the player, I'm going to make a new layer. I'm going to call this player. All of this rhymed. I promise you that wasn't intentional. I'm going to add player to the layer. And let's just say this object only. It doesn't really matter in my case because I only have one collider. It will have to hit colliders, and that's on this character. Which is also where that we have the player controller script. Now we want to figure out exactly how do we damage the player. One way I personally prefer doing this is actually by having the server keep track of all the players and the stats of the players. So let's set up this now. Let's make a new script, and I'm just going to call this the player manager. Then I'm going to make a new empty game object. I'm just going to call it the game manager, and I'm going to attach the player manager to this. The game manager is also where you could hold data about how your game works, or if events triggers, and so on and so forth. Now inside of this player manager, let's make a new class, and let's call that class for player. Now we got to figure out exactly what does the player have. So let's have a public integer, which is the health. We can figure out other stats later if we want that, and we can just simply add these to our class. Now we also want a dictionary. I prefer working with dictionaries now after what Yarncat has taught me. So let's make a public dictionary. And the way the dictionary works is they have a key and they have a set value. The key is what you'd use to identify something in your dictionary. So in my case, I'm going to use an integer, which is a number. This could be player 0, player 1, player 2. But that's actually identifies already in Unity, which you can use. So the value is going to be our new player class, and we're going to call this dictionary players. And then we just need to identify it as a new dictionary, like so. And here we go. Now we have a full dictionary of our players, and we can actually start making some functionality with these. So for example, one part of the functionality could be a public void that's called damage player. We would need the integer of the player or the key. So let's call it this player key. Or let's call it player ID. That might be easy for you to remember. So this is the player ID, and let's also have an int for the damage to deal, like so. And now it's actually super easy. We can enter the player's dictionary. We can feed it the player ID. This is how we find out which player we are getting. And we can say .health minus equals to damage. Now what we can also do immediately, since we're damaging the player, we can have a check checking if the player is now dead. So if players at the player ID dot health is less than or equals to 0, which means we're dead, we want to kill the player, or the player's dead. So let's make a void called player killed. So in this void, we're again going to need the int for the player ID, and that's basically it. Now you could also in here have the ID of the player that killed him. You would just need to send it in here. So you would send the attacker. Actually, let's do that immediately. Int attacker ID. You guys might want this, so let's do int attacker ID. Now in my case, it doesn't really matter if the player is just damaged and nothing else happens. I don't need to use the attacker ID. But what I can do is I can send the player killed functionality with the player ID and the attacker ID. So we can just print and say that player plus player ID.toString was killed by, and then attacker ID. So in this case, we'll only be getting the IDs, but you could also keep track of the names and stuff in here if you want that. So you can pretty much use this to keep track of everything that you want to know about the player. You could also keep track of the network connection that they might have to be able to send target RPCs and so on and so forth to them. But might look into this later. But not for now, we're gonna know if we've killed the player. And for that sake, we can also just send a print saying that player ID.toString is damaged and then the damage amount. So now we can keep track of the damage that we deal to another player. Now let's first of all also remember to make this a network object script. Let's make it a network behavior script, like so. We want to check if we are the server, if base.is server, and for that sake, if we are not the server, we want to return, like so. The reason why we want to do this is because we want everything in here to be kept track on by the server. We want the server to be handling absolutely everything. Now, the last thing that we need for this system to work is we actually need the players to subscribe or well add themselves to this list on the server. The way that we do this is we go into the player and we grab the player controller script. Inside of the player controller script, in the onStartClient functionality, we can actually say if base.is server, which means now we're acting as the server. And if we are the server, we want to go to the player manager. Now, if you don't know about the singleton instance setup, it is extremely useful. So the way that this works, let me just set it up first. Public static player manager, we're going to call instance, and then we're in the awake function, we're going to say instance equals to this. Now what this basically allows for you is that we're basically saying if there's only one player manager, we're only intending to have ever one player manager in here, we can actually call it by now writing player manager.instance, and we automatically just grabbed this instance of the player manager. This means that we can now write player manager.instance and we're in. Now we can say .players.add, and we can add the needed values to this dictionary. So what do I want the key to be? One thing that's actually really useful about Unity is that you have the game object.getInstanceID. The instance ID is, well, an identifier for the object because it's unique to only the object. So this is what I'm going to use. There's a lot of different things that you could use. You could use the client's connection or something else, but in my case, I just want to use the object ID. Now we also need a player manager.player. That's because that's the class that we've added, and it's a new one that we're making. And let's populate it. The way that we populate it is just we open the curly brackets, and the only thing that we can set is the health. And since we're just in the start of the game, let's just set the health to 100. So now whenever a player joins, the server will automatically add this game object instance of the player. The reason why this is useful is now whenever that we hit a player, we can actually have the server check that player. So the way that this works is we're going to make a server RPC, say require ownership equals to false, and then void hit player. And we're going to need some information in here. We're going to send the game object over the network, which is the player hit. And now the server can actually send this over to the player manager.instance.damage player. And then we can get the player ID because we've just sent the game object. You've got to remember, you cannot send the player ID from here because the server instance and the client instance might be two different ones. So it's important that it's the server that gets the object's ID. This is why we're sending the entire object in this case. So we can say player hit.getInstance ID. Now we also want to send the damage, which we know that's just damage. And then we need the attacker ID, which we can also get because that's the game object that we're on. Game object.getInstance ID, like so. And there we go. Now we're sending all the data through. Now we just need to call hit player from here. and we can call it.transform.gameObject, and that should basically be it. Now let me just take you through some of the logic again. So locally on the player, we're going to shoot. If we do hit a player, which is what this makes sure that we do, we'll call the hit player functionality. The hit player functionality will then be called on the server, which will then go to the player manager, the instance of the player manager, and call damage player. Now let's go to the player manager, and keep in mind right now we're interacting as the server. So that means that we're going to damage player, which means we get past this check because we are the server. If we were not the server, we would be thrown out again. But since we are the server, this doesn't matter. And it will go and it will grab the player.health and damage the player. And then it will tell us that the player was damaged. We could actually also just instead just say health is, and then just send the health through instead. Actually, that might make better sense. Player ID.health. There we go. Now let me go build the game and let's test it. One thing that's also important to do is remember to set up the player layer within the player shoot script on the player prefab. Player as the server or the host in the Unity version, and in the build version I'm just gonna join as a client. So now if I run over here and let's go to Unity again, and we're gonna click the mouse button on him, you can see player with this ID, health is now falling. If I'm just holding down the mouse, you can see the health is constantly falling because we're constantly hitting him. And the other thing will also work the other way around, which you can see now when I'm shooting, you can see the player with the other ID is now also taking damage. So now we're perfectly fine tracking the damage on the server. So let's also in the player class keep track of how many players that you've killed. Public int kills, and let's also keep a public int for deaths. Now whenever a player is killed, we know that we can call this in here. So we can take the players at the player ID dot deaths ++, and we can take the players at the attacker ID dot kills ++. The ++ obviously means that we just add 1 to the number. So also one thing that I forgot is we need of course to reset the player's health. So we're going to say health equals to 100 whenever they are dead again on the player ID. So whenever they're killed, the health is reset to 100, and now we just need to reset their position. Now for this, since let's just go out and have a look at the player prefab, and if we scroll down on the network transform, you'll see here that it says client authoritative. This means that the client is actually the one able to move the network transform object. Now for this means that we actually need to target the player. But this can be used with the target RPC, which is not actually something I've featured on this channel, I believe, before. While we set up the player, let's go into the game manager and say using Fishnet connection. So we need to be using Fishnet.connection at the very top. And then inside of the player, we also have a public network connection that we're just going to call connection. This connection is something that's specific to Fishnet, where you can keep track of players' connections. This was also what I was talking about that you could be using as an identifier. So to be able to get the player's connection, we actually need to get, so let's say get component network object.owner. This way we're getting the owner's ID of this object that we're currently on, which is the player's object. So now we're getting the owner's connection in here as well. And what we need to do now is we need to tell the owner to move the player. This is actually super simple. Now that we've added the network connection, we can use the target RPC. So the target RPC is basically just sends the function that we're writing now to only the targeted network connection, which means it's only one player that runs it. And obviously, since we're manipulating the player object, just the owner of that object to manipulate the object itself. So let's just do void respawn player. And in here, we want the network connection. I'm just going to call it con. We want the game object, which is the player object, and we want an integer for which spawn to use in the list of spawns that we have. So now in here, I'm basically going to do player.transform.position equals to spawn points at the selected spawn. .position. There we go. Now we're setting the position. Now, of course, we need to call it from up here. So let's call respawn player. And this can be in the players.playerID.connection. It is the players at the player ID dot player object. And let's just pick a random spawn by using random.range from 0 to the spawn points.count. So the length of the list, which means that we're basically just picking between any of the spawn points that we now have available to us. You can of course use more advanced methods to make sure players don't spawn on top of each other and so on, but this is just the basic setup for now. And this basically works with most setups. However, if you're like me using a character controller, this means you're using character controller.move, which has some issues with this. But there's actually a really easy solution. Just to explain the issue really briefly, if you don't use a character controller, this doesn't matter to you. But if you do, this actually matters quite a lot. The issue with character controller is it basically has its own understanding or its own variable for its position in the world, which means it actually doesn't use transform.position the same way that you might think it does. It doesn't just add to the transform.position, it adds to its own version of that. So the way that you can synchronize these to make sure is just before you run character controller.move, you can just do physics.sync transforms. This way that we make sure that the character controller's understanding of where we are in the world is the same as the transform.position, which is what we're manipulating here. I hope this makes sense. So let's go out and test this. Now let's try and test it. I'm going to join like so. And let's just put the server up here and let's shoot him a couple of times. 1, 2, 3, 4, 5. And there we go. He respawned over to this spawn position. Now let's shoot the connection. 1, 2, 3, 4, 5. And there we go. He respawned to this position as well. It's completely random. If I shoot a couple more times, you should see that now he spawns over that. So as you can see, now it works. We have functioning shooting and respawning, and we also keep track on the server of the players, which is pretty much the most important part for the setup of this. We are technically also tracking the kills and deaths, but we're not using this for anything. This is where you can implement something like a scoreboard. You can also start working on implementing shooting animations, and so on and so forth. There's a lot of things you can do with an FPS. If these are things you'd like to see tutorials on in multiplayer as well, let me know in the comments and I'll look into it. But I really hope that this at least helps you set up a decent understanding of a base of how to work with this. As you can see, it's actually super simple. If we take away from the fact that we of course already had the player controller script, this whole setup has basically only been around 56 lines of code here and around 60 lines of code here. If you find it useful, a like and a subscribe is very much appreciated, and I just hope that you have a wonderful day.